Alright, so solutions to the homework of topic 7, special parts of a triangle. So first of all, there are some challenging problems after the lecture, so let's have a look at these questions first, okay? So question 1, find the area of ABCD given that AB equals BC equals 6 and CD equals 3 square root 2 and angle ABC is 90 degrees. Okay, so basically we have a right triangle ABC, right? And angle B is here. ABC is 90 degrees. So we don't know much about figures with 4 sides at this point, but we now know a whole lot about triangles, right? We can start with the right triangle ABC. So we know there is a circle passing through all 4 vertices of ABCD. So if there is a circle that passes through all the vertices of triangle ABC, we know that circle is called circumcircle, right? And we know that circumcenter must be the midpoint of the hypotenuse AC, right? So that circle must be somewhere here. Okay, sorry. I'm gonna draw this circle manually. Okay, so that's the circumcircle of triangle ABC, right? And there is some point D here. And CD is 3 square root 2. We can then connect C and D. Okay, this is point D, and this is a point O, which is circumcenter of the circumcircle, right? And AB is 6, BC is also 6, so this is a triangle ABC is actually a right isosceles triangle, right? And CD, this length is 3 square root 2. And we need to find the area of A, B, C, D. Okay. Okay, first of all, we know the area of triangle ABC, right? So as long as we can find the area of this triangle ACD, then we can use the area of ABC plus the area of ACD, right? To get the area of ABCD, right? So let's write, first of all, the area of triangle ABC is 1/2 of 6 and another 6. 2 legs, right? Which is 18. And unfortunately, we don't have much information about triangle ACD, but we do know that circumcenter of triangle ABC, the midpoint of AC here, and also we know triangle ABC is isosceles right triangle, so AC is very easy to find, right? AC equals square root of 6 square plus another 6 square, which is 6 square root 2. And because O is the midpoint, OC is 3 square root 2, and AO is also 3 square root 2, right? And the radius of the circle is 3 square root 2, so we know OD is also 3 square root 2, right? And we also know that triangle OCD is equilateral triangle, right? So each of these angles is 60 degrees, and then angle AOD equals 180 degrees minus angle COD, which gives us 120 degrees. This angle here is 120 degrees. And triangle AOD is also isosceles triangle, right? This side equals this side. And each of these angles is 30 degrees, right? And therefore we know actually ACD is also a right triangle. and angle ADC is 90 degrees. Therefore, we know the area of triangle ACD equals 1/2 of CD times AD, right? Which gives us 9 square root 3. And therefore, we know the area of ABCD equals the area of ABC plus area of ACD, which is actually 18 plus 9 square root 3, right? And the key is to establish the diagram by yourself, according to the given information. Any questions? Okay, if you have any questions, just let me know, okay? Otherwise, we'll move to the next one. Okay, challenge question number 2. Given AB equals AC equals 10 and AC equals 12, find the circumradius, the in radius of triangle ABC. Okay, so triangle ABC is a isosceles triangle. AB is 10, BC is also 10, right? So this point here is C, and AB equals BC. Oh, sorry, made a mistake here. This point is B, this point is A. So AB equals BC. So this length is 10. Okay, since we are looking for circumradius and in radius, we are thinking about perpendicular bisectors, right? And of course, angle bisectors. Our triangle is isosceles, so we'll start with a special line from the vertex angle B, since they're all the same line, right? For example, if you choose a midpoint of AC, then connect PB, then we know PB is also perpendicular to AC because triangle BAC is isosceles triangle. AB equals BC, right? So BP splits our triangle in two congruent halves. Also, this angle equals this angle here. So AP should equal 6. PC is also 6, right? Since triangle BPA is right, so we have BP equals 8, right? According to the Pythagorean theorem, it's very easy to find BP is 8. And to find the circumradius, we can build a right triangle with the circumradius as the side by connecting the circumcenter. So suppose O is the circumcenter, then we connect AO. And we can let OB equals X. So this side is X. And first of all, we have already solved BP equals 8, right? So OP must equal 8 minus X, right? And then we can apply the Pythagorean theorem to triangle OAP. OAP here. So we have OA square plus, equals AP square plus OP square, right? OA is X square. AP square is 36 plus OP square. OP square is 8 minus X square, right? And simplify this equation. Then we can cancel a X square here. Then we have a equation in terms of X. 16X equals 100, right? Therefore, we can solve X equals 100 over 16, which is 25 over 4. So the circumradius is 25 over 4, right? at the circumradius. Since the area of triangle is its semi-perimeter times its in-radius, then if we know the semi-perimeter and if we know the area of that triangle, we can quickly find the in-radius of triangle ABC, right? So we can say because the area of triangle ABC, we have learned this formula, right? Equals R times S. R is the in-radius, right? And S is the semi or semi-perimeter. Then we know we want to find in radius R, so R equals the area of ABC over S, right? And we know the area of ABC can be calculated using 1/2 of AC times BP. And we also know the semi-perimeter, which is 1/2 of 10 plus 10 plus 12, right? Therefore, we can cancel a 1/2 here. AC equals 12, BP equals 8, divided by 32. And eventually this gives us 3, right? So we know the in radius is 3 and the circumradius is 25/4. Any questions? Okay, please note that this formula is very important. Alright, if no questions, let's have a look at the next one. Again, this time the diagram is given to us, so that lowers the difficulty level of that question. In this diagram, AD bisects angle BAC. That means BAD equals angle DAC, right? Which is illustrated here. And I is the in-center of triangle ABC. So there must be a circle like this. I is the center of that circle. Furthermore, AB equals 7, BC equals 8, and AC equals 11. The question asks to find a ratio, which is AI over ID. So here we are looking for a ratio and we have an angle bisector. So we can try using the angle bisector theorem, right? Since I is in center of triangle ABC and BE also bisects angle ABC. This angle equals this angle here, right? Therefore, BI is an angle bisector of ABD. So from the angle bisector theorem, we can have AI over ID equals AB over BD, right? You follow me? And we also know that AB equals 7. So if we can find BD, then we are finished. You can find the ratio here, right? So the key is to find BD now. The angle bisector theorem also gives us AB over BD equals AC over CD, right? One applied to angle bisector AD of triangle ABC. So since we have BD plus DC equals BC, which equals 8, then we have 7 over BD equals 11 over 8 minus BD, right? Therefore, we can easily solve BD. So by cross multiplication, we have 56 minus 7 BD equals 11 BD, right? And of course that gives us 18 BD equals 56. Therefore BD equals 56 over 18, which can be simplified to 28 over 9, right? So now we have both AB and BD. Therefore we know AI over ID equals AB over BD, which gives us 7 over 28 over 9, which is 9 over 4, right? Any questions? Again, this question really checks your understanding of the angle bisector theorem. So here we're using it twice. Alright, if no questions, let's have a look at the next one. Okay, is it possible for there to be point E and F on side BC of triangle ABC, such that BE equals EF equals FC and angle BAE equals angle EAF equals angle FAC? Explain your reasoning. So here we have both angle bisectors and lengths, right? So we can try the angle bisector theorem as well. Okay, first let's draw a diagram. Okay, vertex A, B, and C. So A and AF trisects angle BAC, right? We have AE here and AF here probably. So this angle equals this angle equals this angle. And also if we can also treat this line AE is the angle bisector of BAF. And this line here is the angle bisector of EAC, right? Then the suppose AE and AF trisect angle BAC. Then according to angle bisector theorem, we have AB over AF should equal BE over EF, right? And AE over AC equals EF over FC, right? If that BE is also equal to EF and equals FC, so let's suppose if BE equals EF equals FC, then we actually have AB over AF equals BE over EF equals 1, right? And of course AE over AC equals EF over FC, which is also 1, right? Therefore we have AB equals AF and AE equals AC, right? Which means AB here. Well, let's use different colors to denote that. So AB here equals AF, and we also have AE equals AC, right? This is according to our assumption. So making these equalities in our diagram, congruent triangles then jump out. Specifically, according to SSS, we have triangle ABE must be congruent to triangle AFE, right? You see that? And also congruent to triangle AFC, right? According to SSS. However, this means that angle AEB must equal angle AEF, which equals 90 degrees. And also angle AFE equals angle AFC equals 90 degrees, right? And triangle AEF has two right triangles. Has two right angles, and we know this is not possible in a triangle, right? Not possible. So why it's not possible here? So why it leads to a conclusion like this? If it's not possible, then there must be something wrong with our assumption, right? So this assumption and this assumption here cannot be true at the same time, right? Therefore, we know okay, should say therefore our assumption is not correct. Then you should state that it is not possible for there be the points such that BE equals EF equals FC and angle BAE equals angle EAF equals angle FAC at the same time, right? So you should write this by yourself. I'm not gonna write it here, okay? So this completes the reasoning process of this question. You get it? All right, if no questions, let's have a look at the next one. Okay, here we have point E is the midpoint of AC and AD the median of triangle ABC. So first of all, let's draw a triangle ABC. ABC. E is the midpoint of AC. So let's say E is here. And AD is the median of ABC. So D is also midpoint of BC, right? AD is the median. F is on AB such that AF equals a quarter of AB. So this is half of AB, then a quarter of AB must be somewhere here, right? And this is point F. Well, let's call the midpoint of AB is K. EF and AD meet at X, so EF. Let's connect E and F. And AD meet at X, so this point here is X. Find AX over AD. Okay, first of all, let's connect. Okay, if E is the midpoint, D is midpoint, then if we connect BE, that point here is called the centroid, right? Which is the intersection of all medians of the triangle. So if K is midpoint here, if you connect KC, all of the three medians will meet at a point here, right? So let's call this point as G. Okay, so we basically have a diagram like this. We need to find AX over AD. Okay, first of all, if K is the midpoint of AB and AF equals a quarter of AB, then F is the midpoint of AK, right? This part equals this part. Therefore, we have triangle AFE is similar to triangle AKC, right? By SAS similarity. You see that? Because, well, if you write reason, you should write AF over AK equals AE over AC, which equals 1 over 2, and it shares the same angle. FAE equals angle KAC, right? Therefore, by SAS, they are similar, and therefore we can prove angle AFE equals angle AKC, right? Therefore, we know these are corresponding angles, so we have EF must be parallel to segment KC, right? And this gives us, if we have a pair of parallel lines, then we have triangle AFX is also similar to triangle AKG, right? According to AA similarity. And therefore we have AX over AG should equal AF over AK, which is 1 over 2, right? And since G is a centroid of ABC, this gives us a very important property of the centroid is AG over AD is 2 over 3. Remember this? So we have AX over AD, this is the required ratio, equals AX over AG, then times AG over AD, right? We know AX over AG is 1 over 2. We also know AG times AG over AD is 2 over 3. So eventually we have AX over AD is 1 over 3. Did you get it? Any questions? No? Alright, then that completes challenging questions after the lecture slides. Next, let's have a look at your homework. Okay, question 1. ABAC and BC are tangent to the circle O. Angle A is 70 degrees. Angle B is 72 degrees and angle C is 38 degrees. And what is the measure of OAB? Okay, since O is in center of a triangle ABC, we know OA is the angle bisector of angle CAB, right? You follow me? Because the in center is a point of intersection of all three angle bisectors in the triangle, right? Of course, then we will have angle OAB is just the 1/2 of angle BAC, right? Which is 35 degrees. You get it? Very straightforward question, right? Any questions? No? Alright, then let's have a look at number 2. Find RZ in the figure at right if PR equals 9, QZ equals 4, PQ equals 6, and PZ bisects angle QPR. Okay, and because PZ bisects angle QPR, then one of the properties of the angle bisector is we can have QZ over QP equals RZ over RP, right? By the angle bisector theorem. Again, it checks your understanding of the angle bisector theorem. And therefore we have QZ over QP is 4 over 6, right? RZ is not known to us, but we know RP, which is 9. And of course you can solve RZ, right? RZ is 4 over 6 times 9, which is 6, right? Any questions? All right, so if no questions, let's have a look at question number 3. D and E are midpoints of side BC and AC of triangle ABC in the diagram at right. AD and BE meets at G. AG equals 9, GE equals 4. Find the length of GD. This length and BG, which is here. Okay, so if E is a midpoint, D is a midpoint, then AD is the median of the triangle. B is also median, right? The intersection of two medians or three medians is called the centroid of a triangle, right? And if a centroid of the centroid of the triangle divides each median in a 2-to-1 ratio, right? With the longer piece connecting to the centroid to the vertex. So you could say here because AD and BE are medians of triangle ABC, then we have AG over GD equals BG over GE equals 2-to-1, right? Therefore, we have GD equals 1/2 of AG, which equals, we know AG is 9, so GD is 9 over 2, right? So that solves GD. And of course, using the second ratio equation here, we have BG equals 2 GE, which gives us 8, right? Again, pretty simple question here. Do you have any questions? No, okay. Amber? Any questions?
No.
All right. Okay, next one. The three medians of the right triangle ABC intersect at G as shown here. Again, G is a centroid of the triangle, right? And we know AC is 8 AB is 15. Find the following. First, the area of triangle AFC. So we know that medians ADB and CF divide triangles ABC into 6 smaller triangles of equal area, right? So basically this equals this equals this equals this equals this equals this, right? All of the small areas are equal. The area of triangle ABC is, because it's a right triangle, so it's just 1/2 of AC times AB, right? Which is 60. So each small triangle here has area 1/6 of 60, which is 10, right? Therefore, triangle AFC equals, where is AFC? AFC has 1, 2, 3 of these smaller triangles, right? Which is 30, right? So let's write one more step. So triangle CEG equals area of triangle CDG equals BDG, which equals BGF, also equals the area of AGF, AEG. All of them, each of them is 1/6 of 60, which is 10, right? And AFC has 3 of them, so AFC equals 30. So that completes the first question. Second question, from part B, we know that each small triangle has area 10. So triangle AEG here is just 10, right? Which is already calculated here. And next, triangle DEF. This is also special triangle, right? Triangle DF is a medial triangle. That triangle is called a medial triangle of triangle ABC, right? We know that medial triangle has area of 1/4 of the triangle ABC, right? So we can directly write the area of triangle DEF is just 1/4 of the area of triangle ABC, which is 15, right? And last question, the length of CG. Again, triangle FAC is a right triangle with legs 15/2 and 8, right? So the length of its hypotenuse CF is calculated as this. So we can consider this triangle, right triangle here. In right triangle ACF, you know AF equals 15/2, AC equals 8, and therefore CF is given by square root of 8 squared plus 15/2 squared, right? And this number is square root of 481/2. And because G is a centroid, of triangle ABC, then we know the ratio between CG over GF is 2:1, right? Or CG over CF is 2:3. Therefore, we know the length of CG can be given by 2/3 of CF, right? Which is 2/3 times the length of CF, which is square root of 481 over 2. And this gives us square root of 481 over 3, right? Okay, have a look at the solution here. And let me know if you have any questions, okay? Okay, if you don't have any questions, let's have a look at the next one. Question number 5. RC and QB are altitudes of triangle PQR as shown on the right. Angle QRP equals 20 degrees and angle QPR is 32 degrees. Find the following angles: A, PQB. Okay, this is pretty straightforward, right? Angle PQB is just 90 degrees minus 30 degrees, 32 degrees, or if we write it one more step, minus angle QPB, right? Which is 90 degrees minus 32 degrees, so apparently that's 58 degrees. And for question B, CRP, again, this is not difficult. Angle CRP equals 90 degrees minus angle CPR, which is 90 degrees minus 32 degrees, which is also 58 degrees, right? For question C, angle CQR equals angle QPR plus angle QRP, right? And this gives us 32 degrees plus 20 degrees, which is 52 degrees. For the last question, angle CQB equals angle QPB, then plus angle QPB, right? Which equals 32 degrees plus 90 degrees, which is 122 degrees, right? Okay, have a look at the solution here. Any questions, just let me know, okay? All right, next one. You are given a diagram here, and B, Y, and XA are altitudes in the side Z, XZ and YZ respectively. We know YZ is 15, YB is 12, XA is 10. And we're trying to find the area of XYZ, length of BZ, length of XZ, length of XB, and length of XY. Okay, first of all, area of XYZ is pretty straightforward, which is 1/2 of XA times the corresponding altitude or height with the corresponding base, zy, right? Which is 1/2 of 10 times 15, so that gives us 75, right? Okay, second one, the length of BZ. Okay, we can, if you want to find BZ, we can use the right triangle BYZ, right? So we can say in right triangle byz, we have bz equals square root of yz square minus by square, right? Which gives us, well, if you put all values in, we have 9 for the length of bz. And for question C, because we have area of xyz equals 1/2 of xz times yb. Then we have xz times yb equals, well, we already know the area of xyz, which is 75, right? Therefore, we know xz should equal 75 times 2 over yb, and this gives us 25 over 2, right? And for question D, of course, we have xp equals xz minus bz, which equals 7 over 2, right? And for last question, xy. So in right triangle xby, we have xy equals square root of xb square plus by square, right? And this number here is 25 over 2. Okay, have a look at the questions here. Let me know if you have any questions, okay? Alright, if not, let's have a look at the next one. Okay, so question is pretty straightforward. In triangle PQR, which is a right triangle, we have PQ equals 12, QR equals 16, angle Q is 90 degrees. So first question is very easy, right? The area of the triangle is given by 1/2 of the two legs of the right triangle, PQ times QR. So that is 1/2 of 12 times 16, which is 96, right? And second question, circumradius of PQR. So we know PQR is a right triangle, right? The circumradius equals half of its hypotenuse. So we have to find this hypotenuse first. So PR equals square root of PQ square plus QR square. And then this gives us 20, right? And therefore the circumradius is 1/2 of PR, which is 10, right? Okay, next one, the area of a triangle. Again, we can use that formula. The area of that triangle equals its in radius times its semiperimeter, right? And we know the area of that triangle is 96. In radius is unknown, so let's just keep it there. Times semiperimeter is 1/2 of 12 plus 16 plus hypotenuse 10 here, right? So plus, oh sorry, 20. And of course we know the in radius is then 96 times 2 over, okay, 28, 48, which gives us 4, right? Alright, if you haven't done this, give it a final look and No questions, we'll jump to the next one, okay? All right, if no questions, let's see the next one. Question number 8. In right triangle ABC, altitude AD, so altitude, that means AD is perpendicular to BC, intersects angle bisector BE, so this angle equals that angle here at point X. If angle BAC is 117 degrees, and angle ACB is 35 degrees. Then determine the angle DXE, which is this angle here. Okay, so first of all, in triangle ABC, we have the following relationship. Angle ABC equals 180 degrees minus angle BAC minus angle ACB, right? So that gives us 180 degrees minus BAC is 117, ACB is 35, so angle ABC is 28 degrees. So each of these two little angles is 14 degrees, right? Which means angle DBX equals 1/2 of triangle angle ABC, which is 1/2 of 28 degrees, which is 14 degrees, right? And we also know angle DXE is a exterior angle of triangle DXB, right? Therefore, we have angle DXE equals angle DBX plus angle XDB, which equals 14 degrees then plus 90 degrees, which is 104 degrees exactly, right? Any questions? All right, if no questions, let's have a look at question number 9. Then we can take a short break. Okay, number 9 is no diagram, so it's better to draw the diagram by yourself. Point O is the circumcenter of triangle PQR. Angle QPR is 45 degrees. QPO is 23 degrees. Find RPO. So let's draw the triangle first. So the triangle looks like this. It's a triangle here. Suppose this is a point P, then PQR. So let's call this Q, and this point is R. And somehow we have a circumcenter here, right? O. Okay, we know QPR is 45 degrees. QPO. Okay, let's connect these. So all of the 3 segments are the radius of the circle, right? OP equals OR equals OQ. These three sides are equal. And QPO (23 degrees). Alright, so that means this angle is 22 degrees, right? Okay, first of all, let's write this down. RPO equals angle RPQ minus angle QPO, which is 22 degrees. That solves RPO actually, right? And then OQP. Since O is the circumcenter, it's equidistant from the vertices of the triangle, right? So OP equals OQ equals OR. Since OP equals OQ, we have this angle is also 23 degrees, right? So angle OQP is also known to us. Equals angle QPO, which is also 23 degrees. Okay, then let's consider the second question. Find angle OQR. OQR is somewhere here. We can use triangle OPQ. First, find angle POQ. Twice of 23 degrees, which is 134 degrees, right? And we have this angle here. So because we know OQ equals OR, then we also know angle this angle equals this angle here. Okay, that's right. OP, since OP equals OR, then we have angle ORP equals angle OPR, which is also 22 degrees, right? And in triangle OPR, you can find this angle here, right? Angle POR equals 90 degrees minus twice of 22 degrees, which is 136 degrees, right? So this angle here is 136. This is point O. Then of course you can also find this angle here, right? Now you should be also able to find this angle here. So angle QOR equals 360 degrees, because this is just 360 degrees, right? One full revolution. Minus 134 minus 136, which is 90 degrees, right? This angle is 90 degrees. And then we can consider this triangle. So each of these angles is just 180 minus 90 over 2, right? Did you get it? Okay, Okay, therefore we can conclude angle OQR equals 1/2 of 180 degrees minus angle QOR, which is 1/2 of 90 degrees, which is 45 degrees, right? Yes? Okay, of course, there are some other methods you can use. Just like I said, you can also use triangle PQR. The sum of the three internal angles is 180 degrees. Then 180 minus these two angles, minus this angle, minus this angle, and divided by 2 will give you the required angle here, right? So that's another method. You can choose which one you like. Okay, next question 10 is very straightforward, right? Because BM and AN are medians of triangle ABC, therefore X is the centroid of triangle ABC, and it divides BM and AN such that BX over XM equals AX over XN, right? This ratio is 1 over 2. And using this given information, we have XB equals 2XM, which gives us 7, and XN is just 1/2 of AX, which is 3.6, right? Also, remember this important property of the medians. Okay, next one, segments AD and BE meet at point X inside triangle ABC. Segment CX extended meets AB at F. If these areas are all equal, must X be the centroid of triangle ABC? Well, actually, in this question, you don't have to draw any diagram because using our area equalities, we have triangle AFC equals triangle AFX plus triangle AEX plus triangle EXC, right? Of course, you can also draw a diagram as a visual aid, but I'll just directly write them here, okay? And also equals the sum of these areas and equals triangle BFC. Since AFC and BFC have the same altitude from C and they have the same area, we know that bases AF and BF have the same length. And therefore CF is the median of the triangle, right? And you can use the same method to show. So similarly, using the same method, you can also show B and AD are also medians. Therefore, X must be the centroid. Right? You get it? Okay, next one. Medians AX and BY of triangle ABC are perpendicular at point O. AX equals 12 and BC equals 10. Okay, let's draw the diagram. We have a triangle ABC. This X, this is Y. AX and BY are perpendicular at point O here. AX equals 12, BC equals 10. Okay, first question. Since medians AX and BY meet at O, the point O must be the centroid of the triangle, right? let's say AX and BY are medians, then we have, again, we are using the property of medians. AO over AX gives us 2 over 3, right? Therefore, we know AO equals 2/3 of AX, which equals 2/3 of 12, which is 8, right? That gives us AO. And since X is the midpoint of BC, this side equals this side, this side equals this side, we have BX equals 1/2 of BC, which is 5, right? And OX equals 1/3 of AX, which is 4. So from the right triangle, in the right triangle BOX, we have BO equals 3, right? Because this is 4, this is 5, then this side must be 3, right? And therefore BY equals 2 over 3 times BO, which is 9 over 2, right? That completes the first question. Second question, from the right triangle ABO, we have AB equals square root of AO squared plus BO squared, right? This gives us square root of 73. And median CZ. So if Z is a midpoint, then we connect CZ, then CZ must cross the O point O as well, right? Because it must be crossing the centroid as well. So we have CO plus OZ equals CZ, right? Furthermore, we know that CZ equals 3OZ. CZ equals 3OZ because O is centroid. Since OZ is a median to hypotenuse AB of triangle AOB, we have OZ equals 1/2 of AB, which is square root 73 over 2. And finally, we have CZ equals 3 times OZ, which is 3 over 2 times square root of 73, right? You get it? Any questions? All right, if not, let's have a look at question 13. All right, first of all, prove angle EIC is 90 degrees minus 1/2 of angle A. So angle EIC is the exterior angle of triangle BIC, right? Then we have angle EIC equals angle IBC plus angle ICB, which is 1/2 of angle ABC plus 1/2 of angle ACB, right? And since angle ABC plus angle ACB equals 180 degrees minus angle A, we have angle EIC equals 1/2 of angle ABC plus angle ACB, right? And this gives us 90 degrees minus 1/2 of angle A. This proves the first statement. Okay, then question B, find the length of BC. So from the angle bisector theorem, we can easily see that AB over AE equals BC over CE, right? And of course, this can give us the length of BC is AB over AE times CE, which gives us 16 over 3, right? And in question C, from the angle bisector theorem, we're going to use this again. We have BC over BF equals AC over AF. So if you see angle bisectors, you could use the angle bisector theorem to have some ratios, right? Since we have AF equals AB minus BF, which is 8 minus BF, then AC equals AE plus CE equals 10, and also BC equals 16 over 3. Then we could have 16 over 3 over BF equals 10 over 8 minus BF, right? So basically you have an equation in terms of BF. Of course, you can find BF, right? Therefore, to simplify this equation, will give you 46 BF equals 128. And eventually you can solve BF is 128 over 46, which is 64 over 23. Simplest form. All right. Any questions? Okay, if not, let's have a look at the next one. Question 14. PQ and R are the midpoints of y, z, x, z, x, y, respectively. Midpoints reminds us medians or parallel lines, right? So let's have a look at how we can do this. And ZA is altitude to side XY. So first of all, show that AP equals RQ. As showing the given information, since RQ connects the midpoints of two sides of triangle XYZ, its length is half of the length of the third side of the triangle, right? RQ is just the half of YZ, right? According to similar triangles. Okay, so I'm not gonna write all of them. So according to SAS, we have triangle RXQ is similar to triangle YXZ, right? According to SAS. And of course, you should explain the SAS here. And therefore, we have RQ over YZ equals XR over XZ, which is 1 over 2, right? Therefore, we have RQ equals 1 over 2 of YZ. And since AP is a median to hypotenuse YZ, its length is half of YZ as well, right? So AP is 1/2 of YZ as well. And therefore we have AP must equal RQ, right? And then let's consider the second question. So following steps, similar to those of the first part, we have, okay, I'm not gonna write all of the descriptions here, you should write it by yourself. Because of these, we have AQ equals 1/2 of XZ, right? AQ is here. Because AQ is the median to hypotenuse XZ, right? In this right triangle. Did you get it? We also have RP equals 1/2 of XZ, right? We have already done this in the similar triangles YRP and YXZ. Therefore, we have AQ must equal RP, right? And since AP equals RQ and also AQ equals RP, we have AQ equals RP equals sorry. Okay, AP equals RQ, AQ equals RP, and also PQ equals PQ, right? Because this is the same side. And therefore we can prove triangle PRQ is congruent to triangle QAP, right? According to SSS. And of course, corresponding angles PRQ must equal corresponding angle QAP, right? Did you get it? Okay, have a look at the solution here. Any questions, just let me know, okay? Otherwise, we'll have a look at of the next one. Okay, 15. In triangle PQR, we have PQ equals 8, PR equals 10. QR equals 9. PD bisects QPR. It means this angle equals this angle here. QA is perpendicular to PD, right? So 90 degrees here. And BC passes through A, such that BC is parallel to PR. Okay, first question, prove AC is the median of PAQ. Okay, we can start from the parallel lines. AC is parallel to PR, right? And we have angle CAP equals angle RPA. And because we also know angle RPA equals angle CPA, right? Then we have angle RPA equals angle CPA. These three angles are all equal. Therefore, we have triangle ABC is actually isosceles triangle, right? This side equals this side. So AC equals CP. And because we also have angle QAP equals 90 degrees and angle CAP equals angle CPA, then we have angle QAC equals angle QAP minus angle CAP, which is 90 degrees minus angle CAP, which equals 90 degrees minus angle CPA, right? So from the right triangle, in right triangle QAP, we also have angle AQP equals 90 degrees minus angle QPA, which equals 90 degrees minus angle CPA, right? Therefore, we can see this angle here equals this angle, right? So angle QAC equals angle AQP or AQC. Therefore, we know AC equals QC, right? And because we have already proved AC equals CP, we have QC equals CP. Therefore, C is midpoint, right? And AC is median. Of triangle PAQ, right? Have a look at the solution here. You follow me? And in the second question, we want to find the length of DB. So since BC is parallel to PR, we have angle QCB equals angle QPR, right? And angle QBC equals angle R. So we have two similar triangles. Triangle QCB is similar to triangle QPR, right? So from part A, we have QC over QP equals 1 over 2, right? We have already proved this. And then according to the similarity, we have QB over QR equals QC over QP, which is also 1 over 2, right? Therefore, we have QB equals 1 over 2 of QR, which is 9 over 2, right? So from the angle bisector theorem, we have, okay, I'll just write, from the angle bisector theorem, ABT, we have PQ over QD equals PR over DR, right? Therefore, we know 8 over QD equals 10 over DR. DR is 9 minus QD, right? And the cross multiplication will give us an equation in terms of QD. Therefore, you can actually solve QD, right? So 10 QD equals 72 minus 8 QD. Therefore, QD is 4, right? If QD is 4, then DB is QB minus QD, which is 1 over 2, right? Okay, again, have a look at the solution here. Any questions, just let me know. All right, next one, question number 16. Okay, this time we need to draw the diagram by ourselves. In the right triangle ABC, angle A is 100 degrees, angle B is 50 degrees, angle C is 30 degrees, H is on BC, and M is on AC, such that AH is altitude, so this is AH, and BM is median. M is here. Find angle MHC. Okay, connect H, M. Find this angle here, right? Okay, since AH is the altitude of triangle ABC, we know AHC is a right triangle, so angle AHC is 90 degrees according to given information. I mean the midpoint of hypotenuse AC, right? Of right triangle AHC. So we have HM must equal MC, which also equals AM, right? Also, since MH equals MC, we must have angle MHC equals angle MCH, which is 30 degrees, right? You see that? This side equals this side equals this side. Very straightforward question, right? Any questions? All right, then number 17. In triangle ABC, angle C is a right angle. So let's draw this triangle by itself. ABC. C is here. C is a right angle. Point M is a midpoint of AB, so M is here. Point N is midpoint of AC, N is here, right? And O is the midpoint of AM. O is here. The perimeter of ABC is 112, and ON is 12.5. So let's connect these segments. What is the area of MNCB? MNCB. Okay, so we can, well, in order to discuss easily, we can let BC equals A, AC equals B. So in right triangle ANM, NO equals 12.5, right? Because it's a median to the side AM in this right triangle, right? So it's 1/2 of AM, which is 1/2 of AB, right? And if NO is 12.5, which is a given information, we know MA is twice of NO, then that's 25, right? And M is the midpoint of AB, so we know MA equals MB. Then AB is MA plus MB, which is 50, right? We are given that perimeter is 112. And that means A plus B plus 50 equals 112. Or A plus B is simply 62, right? By the Pythagorean theorem on triangle ABC, we have A squared plus B squared equals 50 squared, which is 2500. Therefore, we have AB equals, well, here is some skills of algebra. AB equals 1/2 of A plus B squared minus A squared plus B squared, right? You see that? And we can put all this number in. So 1/2 of 62 squared minus 50 squared, right? And eventually we have 672. And therefore, the area of ABC is given by 1/2 of AB, which is 1/2 times 672, which is 336, right? And triangle MNA is similar to triangle BCA, right? By SAS similarity with ratio of 1/2. Therefore, MN is 1/2 of A, AN is 1/2 of B, right? You see that? Therefore, we know the area of triangle ANM is simply 1/2 of AN times 1/2 of NM, which is 1/8 of AB, which is 84, right? And finally, we have the area of MNCB is given by the area of ABC minus the area of AMN, which is 336 minus 84, which is 252, right? Okay, have a look at the solution here. Let me know if you have any questions, okay? All right, then let's have a look at the next one, question 18. All right, next question 18. Points M and N are midpoints of PA and PB of PAB. As P moves along a line that is parallel to side AB, which of the four quantities listed below change? Okay, so let's draw a sketch. M is midpoint of PA, N is midpoint of PB. Okay, this is a line that is parallel to side AB. Which of the four quantities listed below change? Okay, first one, we have PM equals 1/2 of PA, right? And angle MPN equals angle APB, and PN equals 1/2 of PB. Therefore, we know triangle MPN is similar to triangle ABP, right? With ratios 1/2. Therefore, we know MN equals 1/2 of AB, right? This is which is a constant. So this ratio does not change. Sorry, this length does not change. So the length of Mn is constant, right? And second question, as P moves, the perimeter of triangle ABP changes. For example, as P moves very far away from A and B, then the perimeter increases indefinitely, right? So this will change. And question C, the area of triangle PAB is given by 1/2 of AB times D, where D is the distance from point P to AB, right? But the length of the base AB is fixed. And since P moves parallel to AB, so is D. Therefore, if AB is a constant, D is also a constant, then the area of PAB is a constant, right? Does not change. Okay, last one. Area of A, B, and M. So we know triangle MPN is similar to triangle APB with ratio 1/2, right? And the ratio of the two areas is the squared ratio of 1 over 2, which is 1 over 4, right? Therefore, we know the area of MPN equals 1/4 of the area of APB, right? And therefore, we know the area of AB and M is the area of APB minus the area of MPN, which gives us 3/4 of the area of ABP, right? And from question C, we know the area of PAB is a constant, so 3/4 of it is also a constant, so that does not change, right? So that's question 18. Do you have any questions? Yeah, the answer is B. B will change. ACD will not change. Yeah, only B will change. Okay. All right, then next one. Okay, let x, y, z. Triangle x, y, z have angle x equals 60 degrees and y equals 45 degrees. A circle with center P passes through A and B on side xy, C and D on side yz, EF on the side. Okay, so basically we have a circle somewhere here, right? Okay, a circle. So x. Let's say this point is x and y and z. And we have some points A, B are here, C, D are here, and E, F are here. Then A proves that P is the in center of angle X, Y, Z. So we could let R be the radius of the circle. Then let S, T, and U be the midpoints of AB, CD, and EF respectively. Since AB equals CD equals EF, we get AS must equal SB must equal CD equals TD equals EU and UF, right? So triangle PSA has a right angle at S. So by the Pythagorean theorem, we have PS squared equals PA squared minus AS squared, which is R squared minus AS squared, right? And similarly, use the same theory, we can prove PT squared equals PC squared minus CT squared, which is R squared minus CT squared, right? And also PU squared equals PE squared minus EU squared, which is R squared minus EU squared, right? And because AS equals CT equals EU, we have PS equals PT equals PU, right? In other words, P is equidistant from the sides of triangle ABC. Therefore, P must be the in-center, right? P is the in-center of triangle XYZ, right? Okay, next, let's try to find angle XPY. So since P is the in-center of triangle XYZ, P must lie on the angle bisector of angle X, angle Y, and angle Z, right? Therefore, we have angle XPY equals 180 degrees minus angle XYP minus angle YXP, right? Which gives us 180 degrees minus 1/2 of angle XYZ minus 1/2 of angle YXZ, right? And furthermore, this equals 180 degrees minus 1/2 of 45 degrees minus 1/2 of 60 degrees. Of course, this angle is 127.5 degrees, right? Can you follow me? Okay, have a look at the solution here. Any questions, just let me know, okay? Any questions? Okay, if not, let's consider the next one. Triangle ABC here has area of 48. P the midpoint of median AM, and let P be the midpoint of AB. If G is the intersection of MN and BP, so G is here, right? Find the area of MGP. The area of this small triangle here. Alright, so first we know that triangle ABM and triangle ACB share the same altitude. From point A, right, to segment BC. And we also know BM is 1/2 of BC, right? Therefore, we know the area of ABM is given by 1/2 of the area of ABC, right? This is very straightforward, which is a 1/2 of 48, which is 24, right? Now in triangle ABM, consider triangle ABM here. We know BP and MN are the medians, right? So their intersection G is the centroid of the triangle ABM. G is the centroid. And the three medians of a triangle divide the triangle into 6 smaller triangles of equal areas. Do you recall that? Which means if you connect AG and intersect with BM at another point, well, let's call it D, then 1, 2, 3, 4, 5, 6. These 6 smaller triangles have equal area, right? which means MGP is 1/6. Just 1/6 of the area of ABM, right? We know ABM is 24, so that's 1/6 of 24, which gives us just 4, right? So area of that highlighted small triangle is just 4. Did you get it? Okay, last question. Question 21, it's the last one, right? It's good. We can finish them all. Circle at the right has a radius 1 and is circumscribed about a equilateral triangle ABC. So each of the internal angles is 60 degrees. X is midpoint of AC. Y is on arc AC such that YXA is right. Then find length of XY. Okay, so there is no center of the circle, right? So we first of all let's use O to denote the center of the circle. So let O be the center of the circle shown here, okay? And since XY is a perpendicular bisector of chord AC, we have already proved that if XY is a perpendicular bisector of a chord AC, then we know it passes through the point O, right? Therefore, we know OY. So let's suppose O is here. Then we know OY must equal the radius 1, right? Since triangle ABC is equilateral, each perpendicular bisector of a side of a triangle goes through the vertex opposite the side. Therefore, actually, if you connect these 2 points, this angle is 90 degrees and it will cross the point O, right? Therefore, we know BX is a median of triangle ABC. And O is the centroid of triangle ABC, right? Therefore, O divides BX such that OB over OX equals 2 over 1, right? That's a property of the centroid of a triangle. And since OB equals 1, then we know OX is 1/2 of OB, which gives us 1 over 2, right? And therefore we can find OXY equals OY minus OX, which is 1 minus 1 over 2, which is 1 over 2, right? So the key is to illustrate once you connect B and X, then BXA must be 90 degrees. This is a property of a line that is perpendicular bisector of AC, right? And also BX cross the point O. Then everything seems very easy, right? Okay, so these are the questions of the homework. I hope you can solve them by yourself already, right? Any questions, just let me know, okay? If you haven't done them all, please spend some time on reviewing of these questions. These questions really conclude what we have learned in this topic, okay? The next time we're going to have a look at another topic, so make sure you are confident about what we have learned so far. Okay, currently we have learned 7 topics. Make sure you are familiar with all the topics now. And I'll upload my notes to Google Classroom. You can download them to review, and you can also watch the YouTube channel. All the videos are there. Okay, I'll see you next time then. Bye.